recording, if your tiny little faces are in the box on the side and you do not appreciate that, or you're running around or whatever, please just turn your cameras off so that your little tiny faces are not recorded and then sent to your little friends, okay? So we're gonna get all started. Like I said, my name is Ms. Marquita. I'm gonna be your instructor for the day, or your scientist. We are not going to be able to answer questions right now, or even really do a whole lot of participating with you guys having your audio turned on. You're gonna stay muted. So if at any point I ask, hey guys, what do you think about this? Or do you think this is a no or a yes or whatever, I wanna see thumbs up and I wanna see thumbs down, or I wanna see waving hands, things like that. That way I can still tell that you guys are participating by showing me your hand signals. Do you understand? Thumbs up if you understand. All right, I saw some hands shaking. Yes, okay, thumbs up. We all understand. First things first, safety. We are gonna be learning all about combustion today. Combustion includes fire. Fire is very dangerous. So I have a ton of safety stuff I need to go over. Not super long, but just a ton of stuff. I'm gonna be wearing gloves today when handling things that are dangerous. I'm wearing a face shield, not only because of COVID, but also because I wanna protect my eyes just in case, and my face, just in case anything flies at me while I'm doing this experiment. I have a fire extinguisher handy. I'm actually gonna move this over a little bit so it's not in the fire zone, because obviously I don't wanna set this on fire, because that would be bad. But at any point, things get crazy out of control, I can help myself by having the fire extinguisher. I also have another adult in the background that if anything ever happens, I hope she runs up and tries to save me. The other thing that I'm gonna be using for safety is I do have my lab coat on. This protects me from getting anything on my clothes, and if anything ever happens to this coat, I can really quickly take it off and then nothing bad happens. I also have closed-toed shoes on because I never want anything falling on my feet. I also have my hair pulled back because I never want my hair to catch on fire, not only because like it took me forever to grow this, but also because that would be super dangerous. I have a lot of hairspray on right now. Okay, we're gonna get started right now. We're gonna talk all about combustion. Combustion is a scientific word for chemistry that includes three things. If we don't have every one of these three things, you cannot get combustion. It includes oxygen, fuel, and heat. Oxygen is everywhere, right? Hopefully. Oh my goodness, how terrible would it be if we didn't have oxygen? Oxygen is everywhere. Today I'm going to be using this torch as my heat source. And then we're going to see what sorts of things we can use as fuel. We're going to be talking all about chemistry. Chemistry is a study of matter. Matter is everywhere. It's everything. It's this, it's this, it's this, it's me, it's you. Ooh. It's getting out of control over here. It's everywhere. And today we're going to be talking all about chemical changes. Chemical changes are when you combine two or more items and you get a brand new thing, but it can't be reversed. It's not like if you have an ice cube tray and you put it in the freezer and you're like, well, this is liquid ice or liquid water, liquid ice, so embarrassing, liquid water, and I want it to be a solid water and I'm gonna put it in the freezer. But later you can pull it out again and it becomes a solid again, right? Has the water changed other than the state of matter? Is water still water? Yes? Yes, water is still water. That is a physical change. It's gone from a liquid to a solid, and then it can go back again. That's a physical change. With chemical changes, we cannot go back and forth, all right? If you were to get a big bowl and start putting a bunch of ingredients in it to make a cake, because we all like cake, hopefully, and then you go and you put all those ingredients in the oven and you cook it, later on if your mom's like, hey man, I was saving those eggs for later, you can't just like stick your hand in the cake and grab those eggs out, can you? Can you grab the eggs out? No, that's silly. That is a chemical reaction. That is a great example of it. But also, chemical reactions are kind of neat because they give you little hints on whether or not they are physical or if they are chemical. Chemical reactions can sometimes give us these hints like a color change or a change in temperature. Maybe it gets really hot once we mix these two ingredients together, or it gets really cold, or sometimes lots of crazy bubbles happen. Like in my last show, I made a giant bubbles and they're all over the floor already. So we're going to talk all about chemical reactions today with combustion. So the first thing we're going to talk about is we're going to go through the different states of matter: solid, liquid, and gas. I'm going to show you how I can use a ton of different liquids as fuels. They're not all the same type of liquid though, and I can already tell you that you're going to notice the difference once we compare them side by side. When I do one, it's going to look very similar to normal fire. The color on it, the shape on it is going to look very similar to normal fire like we have in our fire pits, or maybe if we go out and go camping and stuff. But the other ones after that, they're all going to be completely different colors, and that's because of what they're made of. The chemical makeup of these liquids are actually going to help determine what color they emit when they burn, but also color equals temperature. Did you guys know that? So the different colors in the fire can actually tell you the different temperatures that the fire burns. So the bluest part of the fire is actually the hottest part. Usually I think of blue and I think of like ice or Elsa or whatever, cold, right? That's actually completely opposite. The bluest part of the fire is the hottest part of the fire. And the reddest portion of the fire is actually the least hot portion. So think about that when you're looking at all these different flames. Maybe we can all decide which one we think is the most hot. Okay, are you ready? Thumbs up. All right, I have all my safety stuff, so nobody gets caught on fire, but just in case, Miss Lauren, you have to jump in and save me. So we're gonna get started. I have all of my flammable things behind me for safety reasons, so you can't see all of them, but I'm gonna be using a lot of these squirt bottles. So this bottle actually is labeled isopropyl alcohol. It's a liquid that is a very strong alcohol. In fact, you can use it for cleaning purposes. So it's kind of difficult for us to find it right now, but that's okay. So usually do it like this. Okay, I'm a little thrown off with all the flash chips. Okay, so hopefully this does not light your cameras on fire. Are you ready? Thumbs up if you're ready. 3, 2, 1. So this is basic fire. I don't know why. I always try and blow it out. I have a face shield on. I can't blow the fire out. That's so embarrassing. Okay, so the colors we saw were yellow and orange and maybe some white, not a whole lot of blue. This is actually as hot as I just got by doing that. It's not actually the hottest flame. So we're gonna put this one aside and we're gonna compare the rest of them to the one that we just saw. Are you ready? All right, let's see if some of these. All right, so this is a mixture of chemicals. Remember, when we're doing any sort of science, we need to know what we're doing science with. And if we don't know what we're doing science with, we can't be doing science, all right? We need to know the safety behind it. So I have everything labeled. I know that I should never drink or eat the science. And I particularly know that I shouldn't mix certain types of science. All right, so this is methanol mixed with a special salt called lithium chloride. This is going to be a crazy color. Are you ready? Are you ready? Okay, good. Like no one's screaming at me, so I don't know right now. 3, 2, 1. Oh my goodness. So I think this one is probably my favorite. Just like lighting everything on fire over here. So this one's my favorite because it looks crazy and I kind of look a little bit like a dragon when I'm doing it right. Like if I was like a dragon in one of those fairy tales and I was like, protecting the princess. Then this is the color flame that I would prefer to have as my dragon's breath. But I think this one's super neat too. It's strontium chloride with a little bit of methanol. So like I said, remember the different chemicals emit different flames because they're made of different materials and the different colors show us the different temperatures that they burn at. Are you ready? 3, 2, 1. So this one is much more of a deep red. It's a little bit harder for you guys to see on your screens. It's a little bit of a reddish orange color. There is some blue in here, but I'm going to show you one that actually is such a beautiful blue color. It might actually be a little bit invisible. So I'm actually going to have Miss Lauren turn the lights off behind me, and we're going to see, you guys can see a little bit better. All right, thumbs up if you can still see me. I know you can because I can see myself, but I'm just making sure. All right, so this is methanol. Again, we need to be very careful when we're doing this. You guys are children. You should never do this at home. I should have said this at the very beginning. Don't do this at home. Okay, ready? 3, 2, 1. That's embarrassing. Your squirt bottle doesn't work. Oh, there it goes. Okay. Whoa. All right, so I think you guys should be able to tell. Let me try this again. Using my protective gloves makes this very difficult to do. All right. looking at it up close, you notice there's kind of an outline. Ooh, don't light the counter on fire. My boss is watching this. Oh, goodness. There's an outline around the orange, and that is the blue. So this one actually burns at the hottest. I should be like the most safe with this one. This one burns the hottest than any other of the fires because it has that blue. The blue tells us information, right? One, if it's emitting a color when we mix two things together, it's a chemical reaction. We've already learned that. But also, if they're different colors, that tells us different temperatures when it comes to fire. This can also be related, you can turn the lights back on, related to if we're studying stars. So stars in the sky are also different colorful colors. So that's a pretty fun fact, but we're not talking about stars right now. So we're gonna move. We just did liquids. I'm gonna show you that I can light a gas on fire. And no, it's not gonna be farts. It's gonna be a different type of gas. So hold on while I prep my station, my fart-free station. You always gotta talk about farts in these shows. You always have that one person that thinks farts are gross. Okay, so this is my handy trash can of science. I know it might look like an ordinary trash can, but I'm telling you, I went through a lot of school, and this is my reward for all those years of school. So if you stay in school forever, you can also have yourself a trash can of science. Aren't you excited? She's so excited. She's going back to school to get her own trash can. Okay, so I'm gonna be working with a gas right now, and I'm gonna show you I can actually light that gas on fire. But first, I have to turn this liquid into a gas. Can liquids turn to gas? Thumbs up? Yeah, right? It's that crazy word called evaporation. So I am going to heat up this liquid or add energy to it, and the molecules, instead of being water or liquid, they're gonna be like, whoa, they're gonna turn into gases, okay? So the first thing I'm gonna do is, this is hexane. It turns into a gas at a fairly low temperature. So it's not like water, how you have to boil it and make it kind of hot in order for it to turn. This one turns into a gas at like body temperature. So since I happen to be body temperature, I am going to warm this liquid up. And I'm just gonna have a little bit on the bottom right here. I'm gonna agitate it, meaning I'm gonna move it around and warm it up a little bit. Huzzah! You're welcome. Did you guys see the gas? Did you see it change? No, that's because gas is invisible. Oh my goodness, I can't believe you guys fell for that. So there is gas still in here, and I know because I'm about to light it on fire, and also because I know about hexane. But if you guys don't trust me, I know that hexane gas is very dense, which means even though it's still a gas, the molecules are pretty close together, so they tend to sink or be below other things. Unlike oxygen, oxygen is less dense. It kind of floats around. Or like helium we put in balloons and they go super high, right? So hexane is just gonna like chill in this cup until I let it on fire. Are you ready? Yes? I feel like these kids are like, why is she screaming at us? This one, put her thumb up. She's like, yeah, you're screaming at us. I apologize. I like to scream. Okay, 3. Oh wait, that was a 1. 3, 2, 1. My lighter went out. 3, 2, 1. Is it amazing? Yes? No? Kind of lame? Okay. So the cool thing about this is I'm also going to use this as another way to teach you that we need, she put her thumb down, that we need those 3 things in order for this to continue to be lit. So I have fuel, I have oxygen, and I have heat. But if I take one of them away, what happens? Is it a triangle still? No. So I took away oxygen, meaning this could not continue to be combustion. So I took away the option of oxygen mixing with those 2 items to put it out. This is the safest way for me to put out this flame because it does burn pretty hot and I don't want to burn myself. All right, looking at the time. Okay. Okay, so the next thing we're going to talk about is we are going to talk all about solids. So I'm going to let you guys in on a little information here. I'm really bad at this experiment, so let's hope that this works. All right, so the fun thing about this is we already know that we can light solids on fire, right? Like, how do we make campfires? We don't just like go and grab a bunch of isopropyl alcohol and just hope that it stays lit the whole time, right? No, we put wood in our fire. We burn actual things. So yes, this is a solid. No, it is not ketchup, because that would be silly. But I like to keep it in my ketchup container. So before I light it on fire, I want to show you kind of what it looks like. So I have this fireproof glass, and I have my solid right here, and I'm going to show you that it is in fact a solid. Most of you probably saw that it kind of looked like a powder. Well, powder is still solid. It's just really, really teeny tiny little granules of solid. So I'm going to light this on fire. Are you ready for my fireball of death? It's not going to be that bad, probably. Who knows? But Miss Lauren is here just in case bad things happen. Are you ready? 3. Wait, that's 2. 3. I can't do the 3. 3, 2, 1. Go! Wait a second. Oh my goodness, why don't you think this is working? So I have heat and I have my fuel, but since we need this triangle for combustion, I think something's missing here. And in fact, there is something missing here. Oxygen is missing. So while oxygen is everywhere, oxygen can't always get between these teeny tiny little pieces of our solid. They're just too small and too close together for us to be able to continue that triangle of combustion. So in order for me to light this on fire, I'm gonna have to add oxygen to our mix. So in order to do that, I have to throw the powder up into the air and try and light it before it falls to the ground. Do you think I can do it? This girl's like, nope. All right, well, thank you for having so much faith in me. I'm gonna try and do it anyways, for some of us that are dreamers like me. So I am going to try and do this. And yes, as scientists, sometimes I don't get it right the first time, but that is how we learn. We learn from our mistakes, Lauren. So I'm gonna try and do this. If I can get this lighter lit. All right, are we ready? Thumbs up if you're ready. 3, 2, 1. Ooh, nope, didn't work. All right, round 2, pretend that part didn't happen. Don't laugh at me. 3, 2, 1. Whoa. Did you see it? Did you blink? This girl is like traumatized. She's like, woo! I told you it was a fireball, but also one of the messiest things I've ever done. So let's see if I can do it one more time. Are you ready? Yes? All right. All right, Miss Lauren. 3, 2, 1. Whoa. Crazy, right? I thought it was crazy because most of the time that never works. So you guys are like the lucky few that actually saw me do this correctly. It is very difficult to get this one to work because, like I said, I have to like juggle a bunch of stuff, and fire is actually really scary. So yeah, so mostly that part. So we just learned how we can light solids, liquids, and gases on fire by using them as a fuel. Not all things can be our fuel, but before I let you guys go, I wanted to show you a couple of really cool experiments that I've learned over the few years that I've done this because I'm a trained professional. This experiment is called this needs to balance. Our tornado fire. Are you ready? So this one girl's like, nope, not ready. The way that this is going to work is I am going to put fuel in this glass. I'm going to put it inside my trash can of science. Ooh, and then I'm going to try and light it on fire. But the reason it's called a fire tornado, oh my goodness. I was like, what's that word? Fire tornado is because of the appearance. So the first thing I'm going to do is I'm going to light it on fire, and you're going to see It's just kind of lame. But then I'm going to give it a nice little spin. And the reason that there are all these teeny tiny little holes in this trash can is because it is used for the fire tornado mostly. So it is going to actually create a vacuum. It's going to start sucking air into it. And remember, we need oxygen for our combustion. So sometimes if you add a lot of oxygen or just the right amount of oxygen, you're going to feed the fire. Have you guys ever heard of people saying feed the fire? Thumbs up. Or suffocate the fire, meaning take things away from the fire. So we're going to feed the fire by adding more oxygen to it, and you're going to see it go whoop, and it's going to climb up this container. And maybe Miss Lauren will even turn off the lights for us. Look at that, my handy dandy assistant. All right, we're a great pair, me and her. All right, so we're going to get started. Let me use my stool of science, stepping stool of science. Everything can be for science nowadays. All right, so I'm gonna light this on fire. Ooh, this kind of looks like regular fire, right? Lame. So I'm now gonna turn it into the fire tornado. Woo! I know, some of you guys are impressed with my skills. Some of you guys are not. I think this is really cool because it teaches me that I need to have a lot of education for fire safety. Whenever I make a fire outside, I try and make sure, one, it's not near anything that could catch on fire, but also you have to think of, especially around here, wind. When wind gets introduced to your fire, bad things could happen. All right, even just a little bit of extra wind in a certain direction can cause your fire to move, right? We've all seen flames do crazy things, but if we are getting wind from every direction, all feeding our fire tornado, it's going to climb. It's going to climb so high. It's going to climb as far as it can climb before it runs out of either oxygen, heat, or fuel. So while this is still lit, since I don't want it to be lit anymore, I am going to be very safe and I'm going to put it out by suffocating it, taking the oxygen away. One more thing I want to show you before we get started. Ooh, I shouldn't have cut that open. Is how fire acts in different containers. Again, trash can of science. I don't know why I keep using this. I feel like maybe you guys can see things better on it. I don't really know. So I'm going to use two different containers. This is an experiment where all I do is change one variable. A variable is a part of your experiment. All right, so we have variables in this experiment constantly. We always have oxygen. We're using the same amount of heat every time I use the same little torchy torch. But the different variable that I keep adding to these experiments prior to this one was fuel, right? We've used so many different types of fuels and we've gotten way crazy different outcomes. But right now I'm going to use the exact same fuel, the same amount of oxygen, but different containers. So that's the variable I'm going to change. And now we're going to see how our fire varies or differs when we just change that type of variable. So I'm going to put 3 squirts of our fuel in every container. 1, 2, 3. 1, 2, 3. And I counted them out loud so you guys can see that I'm not a cheater pumpkin eater. I don't know what that noise is over there. We're just going to ignore that. And then I'm going to do my best to light these at the same time. Because I want to show you that the shape of this bottle or this glass will determine how long our fire is lit for. Are you ready? 3, 2, 1. Did you see it? Did you blink? Is this one still lit? No, it's not still lit, but this one is. But we use the same amount of liquid. So what actually happened here is, yes, we had the same amount of oxygen at the beginning, but as our fire starts, it starts using oxygen. And this one ran out of oxygen really quickly because of the shape of that container. But because of the shape of the container, the fire seemed to move up the bottle. Did you guys see that? Thumbs up. It moved up the bottle, like it was like looking for more oxygen, kind of like our fire tornado. So I'm going to show you this at a very large scale. I'm gonna make this super big so that you guys can't blink and miss it, okay? Yes? All right, let me move this stuff really quick. And then after this experiment, Miss Lauren will turn the lights back on and we can answer any questions before we have to leave. So hold on really quick. This is my giant whoosh bottle. This is gonna act just like that teeny tiny little glass, the Erlenmeyer flask that you saw a minute ago, but it's like way more fun because it's huge. So I'm going to add a little bit more fuel to this one than I did the last one because it's larger, but not a whole lot because I still want it to be safe. And if you guys were here, I would probably light it a whole lot more, but I want you guys to be able to see the whole thing on the camera. All right, so the big important thing about this is safety. This can be a very dangerous experiment. I have been kind of joking around this entire time, but I take this very seriously because fire actually really scares me. So I have been trained to do this for a very long time. I have adults here just in case you need help. I have a fire extinguisher. I have lots of ways that I can make sure that this is safe. So do not do this at home. Do you understand? Yes? All right, thank you. So we're gonna get started. I'm gonna put my safety back on because I like my arm hair. I'm gonna move this out of the way. I'm gonna brush this up a little bit. Made a giant mess. All right, I am apparently using the birthday party one. All right, are you guys ready? I can only do this once because after I do it, it's all out of oxygen. I can't do it again. Ready? 3, 2, that's 2, 1. Okay, don't blink. Oh man, I should have lit this first. Just kidding. My goodness, what a day. Okay, just kidding. That was a trial run. This is the real thing. 3, 2, 1. Oh, did you guys blink? I hope not. All right, so that is all of the fire that I have to show you today. I hope that you guys learned a lot about chemistry and chemical changes. Like I said, we did a lot with changing variables. We changed the different fuels that we used, the different containers that we used. We even introduced different amounts of oxygen. So remember, when doing science, you need to stay safe. You need to make sure you're not the only one in the room, all right? Somebody needs to be there to help you, especially if you're using dangerous equipment, but also just in case you need help. And then also make sure you understand what you're using, the safety tools behind it, and all that good, great, awesome stuff. Does anybody, Miss Sloan, have any questions for me?
All right, so if you have any questions, why don't you physically wave your hand at me so I can see the screen. Lily Bandy, did you want to ask your question?
I'm scared.
You're scared. Well, don't worry, you are not in the same room as the combustion. And even if you were, Miss Marquita has her safety procedures. Now, does anyone have a question, something they want to know from Miss Marquita? Who, what, when, where, why, or how? Elise, what is your question? Do you want to unmute yourself, Elise B?
What is the video you're recording called?
The name? So this is not a recorded. Miss Marquita is live in front of you, coming from Sci-Tech Discovery Center. So that is a children's science museum in Frisco.
All right, any other questions?
Any questions about the science that Miss Marquita has done while she's in front of you, and you can ask her. Capiche, would you like to ask your question?
Do you have a flamethrower since you're so like with fire?
That is a good question. I actually don't have a flamethrower, but maybe for Christmas I could get one.
Or make one.
Or make one, yes. But on a serious note, that's super dangerous and I probably would never use it. But maybe Santa will bring me one.
Misri, did you have a question?
Since this is gonna record, is it gonna be on YouTube?
So this is actually going to be compiled and then sent to the teachers of the children that could not be here live with us today. So it will not be on YouTube. I will say, however, we do have a YouTube channel that you can follow and go and search for so that you can, people are freaking out, so that you can go and see me or Miss Lauren or other people doing some science experiments that you can maybe do at your house. None of them include fire though, okay? I don't want you guys doing this at home.
All right, Alex Vandestad, I see in your classroom you have a hand up. Did you want to pick the student with the hand there and have them ask their question?
Thanks a lot, Riley. How long did it take you to become a professional person that did this?
How long did it take me to do this? Okay, so I went to school for the amount of time that I need to in order to get a bachelor's degree. And then I started working here, and then they trained me, and now I'm a pro student. But in all seriousness, I went to school and I figured out what I liked to do, which is to teach kids about really cool science stuff. So that is why I'm here. And then it actually took me a couple of months to feel comfortable doing things like this, because like I said, it is kind of dangerous and I'm kind of afraid of fire, which I know it didn't look like I was, but this can be very dangerous. So it did take a couple of years of education and then months of training.
Janae Walsh, I see we've got someone in a cool tie-dye outfit who's got a question.
Yes.
Me?
Yes. So have you ever done this before when you were doing that?
Has she ever done this fire program before?
Yes, like when she was doing, when she was at home. Have you done it before?
Oh, have you ever practiced any experiments like this at home, Miss Marquita?
No, definitely not. My cat is also afraid of fire, so she does not appreciate me playing with fireballs in the house.
So we always make sure that if we're doing an experiment that we can practice at home, we do it at home. But if it's something that has certain safety requirements, then we always make sure to do that at Sci-Tech where we have all of our safety gear. Riley, did you have a question?
Yes. Blue fire is made of, it's made of like plasma, H2O, or nitrogen.
Is that a question?
Say that again, Riley.
I don't think that was a question.
Can you say that again?
I'm just
It did not hit him. It just landed next to him.
So can you say that again, Riley? What were you sharing with the class?
blue fire is basically made of H2 and nitrogen.
Mom, today we're gonna get two.
It's like made of
Or
H2.
at least I already have one. But
That's right,
I have
Riley.
another
So
one after this because this is
when we talk about the
also
states of matter, plasma is one of them. And you're right, when
We're
there
gonna
is
have another
combustion,
brain
fire
break
does give off.
after
Excellent. So that is something, fire is kind of a tricky
because
thing
it's
to
a lot
describe,
of
but it is one of the really cool things to research.
science.
Miss Lauren, I
Lily?
heard other kids talking over you. Can you mute everybody else?
All right,
Yeah.
I'm trying to find that.
She's
All right,
showing
can
us.
everybody make sure that you guys are muted unless I've called your name? All right, so Lily Bandy, did you want to unmute yourself?
I just want to say one thing I can do on this app. I can draw fire.
Oh, cool. That is a hard thing to do.
Okay, so I think Kyra, she's had her hand up for a long time.
How big is the Science Discovery Center?
How big is it? So we actually do have museum exhibits that you can interact with and play with and learn different science. I don't know like square footage of it. It is smaller than the Perot Museum, if that is something that you've ever been to. But it's a pretty good size. You can spend a couple of hours here. If you've never been here, you should definitely look us up. Okay, so I think we have time for like one more question, Miss Sloan. Do you want to pick somebody?
Sahithi?
Have you ever tried mixing two chemicals together and lighting them?
So that is something actually you saw me do. You didn't notice, but some of my liquids actually had two different things in them. So the base of this one is methanol, which is a liquid. And then earlier I added a solid to it that was lithium chloride. So it's a type of salt. So it's a solid, and then it dissolved in it and it actually changed the chemical makeup to be a lithium chloride with methanol in it. So yes, I have tried that. I will say that that can be dangerous. So any of the times that you saw me lighting regular things on fire, like the fire tornado or the big giant explosion at the end, I don't use the super hot burning fire for those because that could potentially melt things that I don't want to melt. So you always want to be careful when adding things together and trying to see if you can light them on fire. You definitely need to do your science before. I had a retired chemistry teacher make sure that we weren't doing anything incorrectly with this, okay? So I don't have that background, but we do make sure that we reach out to people that have that education so we're not doing anything dangerous in front of you guys.
And Ms. Marquita, could you mention how, and New Year's Eve and 4th of July are times that I normally think about this, but how sometimes people mix those different chemicals together on purpose to change their fire?
Yes, so you might not think about it, but that's actually how they make the different colorful fireworks. That's how you get the different blues and the yellows and the purples and things that you see up in the sky. The shapes, however, are different, but that's how they get those different colorful markers when they explode in the sky, is the different chemicals that they're burning. So remember that when you see fireworks. It's pretty cool. All right, well, I wanted to thank everybody for attending. Ms. Warren's going to stop recording now.